In my courses, I always emphasize the importance of problem solving. You shouldn't write code simply for the sake of writing it. Every bit of code you write, you need to understand why you're writing it and what problem you're trying to solve. I've seen a lot of people extracting an interface from every class in their project and call it the best practice because they're using interfaces. As I've mentioned throughout this section, you should use interfaces in situations where you want to decouple a class from its dependencies. And this gives you a number of benefits. The first benefit is that you can easily swap one implementation with another. We have had several examples of this earlier. For example, if you have an algorithm for encoding videos, you may want to replace that algorithm with a faster algorithm in the future. That's a good case for decoupling these classes so you can supply a new implementation in the future with minimal or zero impact on your application. Another case is when you're using third-party services. Let's say today you're using one service for sending emails. Tomorrow, you may want to switch to a different provider. Now, back to our mortgage calculator project. Here we're using this calculator class. It's very unlikely that we're going to replace this with another calculator because the calculation of mortgage and payment schedule is straightforward and doesn't change. We're not going to have a different algorithm that is faster or more accurate. So there is really no need to extract an interface from mortgage calculator and inject it into the mortgage report class, unless you want to do it for unit testing. We'll talk about this later. Another benefit of using interfaces is that you can easily extend your applications, again, with minimal impact. This is particularly useful if you're designing a framework for others to use. For example, let's say you're building a framework for building web applications. Your framework should have a templating engine. You should be able to parse some HTML templates, put some data there, and return a response to the client. Now, you may supply a default templating engine in your framework, but perhaps you want to allow other people to build their own template engines. That's another case for using interfaces. So instead of programming against a concrete implementation, like a concrete template engine, you program against interfaces. Other people can create new template engines that implement your interface. So by using interfaces, you add extensibility points in your framework. And finally, the last benefit of using interfaces is that you can test your classes in isolation. So if a class uses an email service or a storage engine, you can decouple it from these dependencies and test that class in isolation. This is what we call unit testing. That's a topic for an entirely different course. If you don't practice unit testing in your organization, then extracting these interfaces doesn't really give you any values. So once again, don't just blindly write code and follow these so-called best practices because someone told you to do so. For every piece of code you write, you need to understand the problem you're trying to solve. If you're not solving any problems, you're just wasting your time. You're not adding any values. In fact, you're increasing the costs because the more code you write, the more bugs you're going to create, and the maintenance of your applications is going to be more costly.